Hi everyone, this is Dr. Janani here, and in this video I'm going to help you understand some basic concepts behind gravity. Before getting into the slides, I would like to ask you all a question. What if I tell you if you have won a lottery ticket, what will be your reaction? Will you start jumping? What happens when you jump? You go up and eventually come down, right? Have you ever wondered why whatever we throw up comes back to the ground? For example, a ball thrown up comes back to ground, an apple from a tree falls down, but why everything is coming down? Let me introduce you to one of the most amazing forces which we all are experiencing right now without even trying. It is something that holds down everything towards the ground, right? Air, water, you, me, animals, everything is attracted towards the ground. So, the force which pulls you towards the ground is called the gravity. Without this gravity, everything will fly off into the space, right? When you deeply look into the space, you can see so many celestial objects. These are lumps of masses which came together to form some object. Okay, when you look into the solar system, we have so many planets which are rotating around the sun. What makes this planet to rotate? What makes it not to fly away into space? What's pulling them together? Have you ever thought about this? Well, everything comes down to one answer, that is gravity. There is a famous story for the discovery of gravity, apple falling down from the tree hitting Newton's head. I think you all are very aware about this story, but before we getting into that story, let me brush you up with some history of gravity before Sir Isaac Newton. So for this we have to go back in time around 15th 16th century. Okay, that time the people used to believe that Earth is at the center and everything revolves around it. Okay, and few people like Copernicus, Tycho Brahe, Galileo Galilei, Johannes Kepler, all these people believe that Earth is not at the center, rather Sun is at the center and everything is revolving around it. Okay, so the first person, Nicholas Copernicus, he was the first one to propose that Earth is not at the center, but Sun is at the center and everything is rotating around it. But when he proposed this concept to the public, that time he was punished by the people for this idea. And after him, there is another person came, Tycho Brahe. He was from a very rich aristocrat family. He spent his entire life for this purpose alone. And he somehow convinced the king, and he got an entire land from the king, entire island from the king, and built observatory. Okay, built a own observatory, and he employed so many people for him, and they all worked day in and day out for mapping the sky. So he was very famous for the most accurate maps, sky maps of that time. So among the people working under him, okay, there was one person called Kepler joined him. Soon after he joined, in 1 year of time, Tycho Brahe passed away. Meantime, there is one more person called Galileo Galilei. For this, he also believed the Copernicus theory, and he developed his own telescope, and he was also observing the sky. Okay, so he was the person who saw that some objects in the sky are rotating, but it was not rotating the earth, either that was rotating around the Jupiter. And there it is an interesting thing, right? So because that time everybody was believing that whatever is in the space is rotating earth, as earth is at the center. But he observed that some objects were rotating around the Jupiter, and he called them as moons of Jupiter. Okay, so meantime this Kepler, as I said before, this Kepler who joined under Tycho Brahe, after the death of Tycho Brahe, he stole all the maps that were made ready by Tycho Brahe and his team, and came out of the kingdom. And what he did was, he started working on the map, and he observed some really good patterns out of it. He noticed that all the planets go around the sun, but not in the circular orbits, but somehow in elliptical orbits. But he was not like sure why it was happening, but he observed this pattern. So and he observed so many things out of those maps, and he concluded that he came up with three laws. Okay, these are known as famous Kepler's laws of planetary motion. Okay, the first law states that all the planets revolve around the sun in elliptical orbits, having sun at one of its foci. Okay, so from this first law, he says that the orbit is not circular orbit as it was thought, but rather it was elliptical orbits. And for the second thing, he takes the unit area of a planet which as it sweeps around the sun, it in some unit area. If you calculate the amount of area that planet swept in some radius, he observed that it was equal to the some other point where the planet sweeps the area in same time. So he came up with his second law, stating that the radius vector drawn from the sun to the planet sweeps out equal areas in equal intervals of time. Okay, then finally, the third law he proposed was the law of periods. The law of periods states that the square of the time period the planet takes to revolve around the sun, okay, the square of the time period of revolution of a planet around the sun is directly proportional to cube of its semi-major axis, the axis it takes. It is directly proportional to cube of its semi-major axis. So these are the three laws Kepler came up with. The maps, whatever he observed from the maps, he came up with these three laws. These three laws became the foundation for a future study by Sir Isaac Newton. Okay, so after these guys, these four successors and pioneers, there comes Sir Isaac Newton, who discovered gravity. Okay, so let us discuss how Sir Isaac Newton came up with the discovery of gravity. Okay, so according to Sir Isaac Newton, every body in the universe attracts every other body with a force that is directly proportional to the product of mass of the bodies and inversely proportional to the distance between them. Okay, so what it states is, if you take two different masses, it states that every body is attracting every other body in the universe. And one more thing he told was, if the mass of a body is greater, and it will have greater force of attraction, and also if the body is moving out from the center of gravity to a greater distance, then the force of attraction will decrease. Now, the first point, let me explain you with this simple experiment. I am going to drop the stone and feather from some height at the same time. You observe what happens. See, stone falls down first and feather falls later. So the first point what he observed is, greater the mass, greater the force of attraction. Means stone is having higher mass than the feather, so it is attracted, it has more force of attraction, so it falls down eventually faster than feather. Okay, and greater the distance, smaller the force of attraction. See, if you are at the surface of the earth, so the earth's gravity will pull you very strongly, and if you are trying to move away from the earth surface, okay, then you will experience the gravity little lesser. So if the distance increases, then the force of attraction will be smaller. Okay, next, Isaac Newton credited for the idea of gravity when he was sitting under an apple tree in his mother's farm. This is a story behind the discovery of gravity by Newton. This is the famous apple incident story. Okay, he was aware that Galileo's concept of inertia, that is, without an outside force, moving objects continue to move at a constant speed in a straight line. Okay, next point is, force is necessary for an object to undergo a change in speed or direction. These 2 points he was already aware, which was stated by Galileo. So with the apple incident and with these concepts in mind, let's see what Newton did. Okay, Newton saw the apple fall and he looked up through the apple tree branches and noticed the moon. So what he thought is, if apple is falling in a straight line, why doesn't moon fall also in a straight line towards the earth? If both, he observed that the moon is rotating the earth, okay, but it is not falling in the straight line. So he is coming to a conclusion that something is pulling, some force in the earth is pulling apple and the moon. The same force is responsible for both. So he is comparing the falling of apple with the falling of moon. He realized that if the moon did not fall, okay, it is not moving in a straight line, but it leaves an orbit on its own around the earth. So he is thinking what would be the reason. So he came up with one conclusion, that the moon was making a projectile motion circling the earth under some force, okay, that is attraction of gravity, but it is making a circular motion, okay, but which is that force which is making the moon to go in a circular orbit is with a great enough tangential velocity to escape the gravitational pull of earth. As apple did not experience that circular motion because it is very closer to earth's surface, it was falling in the straight line. So to confirm this, he experimented with the cannonball experiment, okay, that we will discuss. So earth and many of the other planets in our solar system travel around the sun. Like the moon is making an orbit around the earth and other planets revolve around the sun in a solar system. So there is a centripetal force which is keeping them in orbit, okay. This centripetal force is responsible for the planets in the orbit, and some same force that pulls an apple towards the ground, okay. These two forces which comes together in a point, which is the gravitational force, one of the Newton's greatest discoveries, okay. Let's now discuss the cannonball experiment did by Newton. So for this experiment, he went on to high mountain top and he took a cannonball, okay. What he did was, he first throw the cannonball with some initial speed, okay. The path of the cannonball, if you see the animation down, the first attempt, it is going in a smaller distance and falling down on the surface, and if secondly he increases the speed, okay, then it is the horizontal distance covered by the cannonball before hitting the ground is increased. So the initial speed was enough to make the cannonball travel a longer horizontal distance before hitting the ground. And he is realizing something with this experiment, that if the initial speed of the cannonball was great enough, then it can go to the curvature of the earth and it may not fall, okay. So he comes up with a conclusion that some force, okay, which made the moon to make the orbit around the earth without hitting on the ground, okay. So that is the centripetal force which makes the moon to rotate around the earth without getting hit on the ground by the gravitational pull of earth. Okay, this is the concept which is used by the satellites to stay in the orbit for observing the earth, okay. So the gravitational attraction between earth and our sun keeps the earth in its orbit around the sun. Same concept he applies for earth also, which is revolving around the sun. So with these observations, Newton came up with Newton's law of gravitation. According to this law, the attractive force of gravity between two particles is proportional to the product of their masses and inversely proportional to the square of the distance between them. So gravitational force Fg is equal to G into m1 m2 by r square, where Fg is gravitational force, G is constant of universal gravitation, m1 is mass of object 1 and m2 is mass of object 2, r square is the square of the distance between the center of the masses. So according to him, gravitational force exists between any two masses regardless of its size, and it always attracts objects to one another. So in this session, I guess you have got some about the basic concepts behind gravity. Also, we have brushed up little about the history of gravity, how people thought about the gravity in those century, and how Sir Isaac Newton came up with his law of gravitation. And before ending the session, I would like to give you some few interesting facts about gravity. So one is the gravitational force is the weakest of all forces that exists. And gravity travels at the speed of light and its range is infinite. Gravity is unidirectional, which means it can only pull and it cannot repel. So gravity is unidirectional. The fifth interesting fact is the gravitational pull is 3 times more on Earth than on Mars, which means if you're weighing 60 kgs on Earth, you will probably weigh only 20 kgs on Mars. Interesting, right? So I guess you people will be very interesting to travel to Mars for this purpose itself. Well, so the last point is gravity can bend light. Have you ever heard about black holes? Black holes are objects which has more gravitational pull in it. So even a streak of light which passes through black hole cannot escape the gravitational pull in it. So the property of the gravity that it can bend light is enormous in black hole. Okay, so gravity can bend light. So with these few facts about gravity, I would like to end the session. So I hope you got some idea about gravity. Thank you.